Alright, so I'm going to be working through the answers to this sheet. I'll particularly spend most time on the first one here. So I'm looking at this function here, y equals 2 sine bracket x plus pi upon 3. So I will need to show some working for this. The thing about this is you have to show working, otherwise you can't work all the things out. So I'm going to write the function at the top. So we were dealing with a horizontal shift. First of all, make sure you understand what each of the things do. So firstly, we've got a horizontal shift of pi upon 3. Now it says plus pi upon 3, which means technically it's moving in the opposite direction, so the negative direction. So it's moving that way by pi upon 3. We can also see that there's an amplitude of 2, and the value of b is 1. So therefore the period has to be 2 pi. Because 2 pi over b, 2 pi over 1 is just 2 pi. So it just has a period of 2 pi. So it's going to be a regular sine graph with an amplitude of 2, but obviously this horizontal shift. So the first thing I need to do is remember the features of the sine graph and think about where those key features are. So the first key feature is that the sine graph starts at 0. So when x is 0, we need to subtract pi upon 3 to get the new position of this new horizontal graph. So 0 take away pi upon 3 is negative pi upon 3. So that's the first key feature. The second key feature of the sine graph is at pi upon 2. So if we take pi upon 2 and we take away pi upon 3, we get the new position. Now, when you're dealing with fractions, it's best to get the denominators the same. So I'm going to get a denominator of 6 in this case. So pi upon 2 is the same as 3 pi upon 6, and pi upon 3 is the same as 2 pi upon 6. So then now you can do this simple calculation, and you can see that 3 pi upon 2, 3 pi upon 6, take away 2 pi upon 6 is pi upon 6. So then the third key feature of my graph is pi. So we want to take away the pi upon 3 from that. And again, it's the same situation. You've got to get the denominators the same. So pi becomes 3 pi upon 3. Take away 1 pi upon 3 is 2 pi upon 3. So that's the third key feature. And of course, then we've got another feature is at 3 pi upon 2. And we subtract the pi upon 3, so that gives us 7 pi upon 6, because that's 9 pi upon 6, take away 2 pi upon 6, which is 7 pi upon 6. And I could keep going, because remember the thing about this graph is it repeats itself. Now you need to just get the main key points where you're going to place them on the graph, and then the next step is then just to follow the repeated pattern. Alright, so this, you must remember the shape of sine. So sine begins at 0 normally, and our new position instead of 0 is negative 2 pi upon 3, so I'm going to put a little cross there. The next position, when sine goes up, was going up at pi upon 6. Well, this is pi upon 3, so pi upon 6 is half of that, and the amplitude is 2. So my new position is going to be there. Then sine comes back down here. Now the new position that we're dealing with is 2 pi upon 3, so that goes there. Now already you can spot a pattern here that you can see by the squares, look, that it goes 1.5 squares this way and then 1.5 that way, and then we know how sine goes. So you can actually keep going. We know that the next position is an amplitude 2, so it's down here at negative 2, and of course our new position was 7 pi upon 6. Well, if you think about this, this is equivalent to 8 pi upon 6, so 7 is half of that. And then you just keep going. So I'm going to go another 1.5 squares there, and I'm just going to completely repeat this cycle for the domain that's here in the question. So if I keep going back this way, go another 1.5 squares, I'm going to sit here, another 1.5 squares, I'm going to sit there, another 1.5 squares, I'm going to sit there. And now all I'm going to do is draw a nice smooth line curve between them. That it should be smooth. It shouldn't be joined by square straight lines whatsoever.